Hello students, my name is Sushant Garg and in this video we are going to see the questions of heat transfers which has been asked in JEE Advanced previous years. The first question of this video or is this video series of JEE Advanced heat transfer is a cylinder of radius R made of a material of thermal conductivity K1 surrounded by a cylindrical shell of inner radius R and other outer radius made of material which has a radius outer radius 2R by a thermal conductivity K2. The two ends of a combined system are maintained at two different temperatures. So up to this point we have read the question. Now we draw the diagram. The outer diameter of the combined compound cylinder we can say is 2R, and there is one other inner cylinder is also available here. This outer structure is made of different material and this inner structure is made of different material and its inner radius is R. So the inner radius cylinder has conductivity K1 and the outer radius cylinder has conductivity K2. Okay, and the two ends of a cylinder are maintained at different temperatures. Suppose this has T1 and this has T2. So if these two ends have different temperatures and if T1 is greater than T2, the heat will flow like this and it will take the cross section area of this portion and this portion. So if we see the side view, so it will look like this. Its radius is R, its outer radius is 2R and inner area is how much? Inner area we can take as pi R square. The outer area is outer area minus inner area. It comes out to be 4 pi R square minus pi R square equal to 3 pi R square. So inner area and outer area both has been taken by the heat when it is flowing. Okay? So this area is how much? A1 and this outer area is how much? A2. So A1 area has conductivity K1 and A2 area has conductivity K2, which is the outer area of the cylinder, and heat is going like this in the cross section, okay, in this direction along the axis of the cylinder, So we can use the weighted mean average to calculate the equivalent thermal conductivity. What has been asked? The equivalent thermal conductivity. There is no loss of heat across the clinical surface and system is in steady state. So rate of heat flow is constant. The meaning of the steady state is this. The effective thermal conductivity we have to calculate when the heat is flowing like this, because two ends have different temperatures and the surface area is not losing any heat. Okay, so heat is going like this. K1 has A1, K1 conductivity is being taken by A1 area and K2 conductivity is taken by A2 area. We will apply the weighted mean average method in which the equivalent conductivity can be said as K1 conductivity has been taken by A1 area and K2 conductivity has been taken by A2 area divided by the total area. This method of calculating the equivalent conductivity is said to be weighted mean average method. So K1 has been taken by A1 area and A1 area is pi R square and K2 conductivity has been taken by A2 area, which is 3 pi R square, and the total area, if we say the total area, how much is the total area? The radius of the outer radius of the cylinder is 2R. So the total area we can say pi 2R ka square 4 pi R square. So this is 4 pi R square. K equivalent comes out to be pi R square, we can take common. So pi R square K1 plus 3 K2 upon 4 pi R square. Pi R square again got cancelled and we get the K equivalent as K1 plus 3 K2 by 4. This method of calculating K equivalent is called weighted mean average. Here we are giving the weightage according to the area occupied by that conductivity. A1 occupies A1 area has K1 conductivity, A2 area has K2 conductivity, and K1 A1 plus K2 A2 divided by total area. This is how we get the K equivalent. This method is applied when the thermal conductivity is constant over a certain area. A1 area has a constant conductivity up to constant conductivity K1, and A2 area has constant conductivity K2. So we applied weighted mean average. Okay, I hope you enjoyed the video, the solution of the question, and in the next video we'll going to discuss the next question which has been asked in JEE Advanced related to the topic of heat transfer. Till then, study hard. We'll meet you in the next video.